Linear-quadratic system. Write the equation for the following linear-quadratic system. Find the equation of the given system algebraically. And we are given here a graph in which we have a parabola, inverted parabola, and a line. Now, as you can see, a parabola represents a quadratic function and line represents a linear function. So, linear-quadratic system is a system where we have at least one line and one parabola to be represented on a graph. Now when the question is, write the solution for the following linear quadratic system, solution means what? Solution here means the points where they intersect. So we find 2 points here on the graph where line and parabola intersects, the points which they have in common. So these 2 points form the solution between the linear quadratic system. So as you know, system is something which has more than one thing in it, right? So here we have 2 things. One, line represented by a linear system and parabola represented by quadratic function. Now from the graph we can always write down the solution of this linear quadratic system. It is, so point, let's say call this point as A, x value is 2 and y value is 1. So we get one solution as 2, 1. And the other one is right there, when x value is minus 1, we have y value of 4. So the other solution is minus 1, 4. So that is the solution to the given linear quadratic system. Now part B is find the solution of the given system algebraically. So my idea is that with this example, let me explain you quite a few points. So one, we have already found the solution looking at the graph. Now, how to find it algebraically? To find the solution algebraically, we need to write equations for both parabola and the line. Now, since we see that the parabola has a y-intercept at 5 and it is moving downwards, opening downwards, and the steps are 1, 3, so it means A is 1, right? So from this vertex, which is at 0 and 5, you can get equation of the parabola, and I can write parabola as y equals 2. This is x squared with a negative number since it opens downwards and has been moved 5 units up, plus 5. So that gives me the equation for a parabola, right? Now for the line, we can get the equation from y-intercept, which is at 3, and the slope. So if I move 1 unit to the right, I'm moving 1 unit down, so negative 1, right? So for my line, the equation is y equals to y-intercept, which is 3, and mx, m is minus 1, so I get minus x. So I get the equation of both line and the parabola. Now, so that is the first part, and that is kind of the tricky part, right? Now the second part is to find solution. Solution here means common points, the points which are common to both. That means for same value of x, they have same value of y. So we can equate these two equations, right? So we say, well, at that point of intersection between line and the parabola, the y values are same, right? So therefore, minus of x squared plus 5 should be equals to 3 minus x. So equate them. After equating, we have to solve for x. This is a quadratic equation, right? So we can take these terms on the right and say 0 equals to x squared, and then we have minus x there, plus 3, minus 5. So that is 0 equals to x squared minus x minus 2. Now you can use quadratic formula to find the x value, or you can factor it. Let's factor. So factoring, product is minus 2 and sum is minus 1. So the numbers are minus 2 times 1. So we get x minus 2 times x plus 1 equals to 0. Now from here, this equation will be equal to 0 at x equals to 2 or x equals to minus 1, right? So those are our solutions. So we have solutions here. X equals to minus 2 will make it 0 at plus 2, and here x equals to minus 1. So at these points, the product will be 0, and that is the solution. So at x equals 2, we can find what y is. We can plug 2 here, right? So if x is 2, then y will be 3 minus 2. So that means y equals to 3 minus 2, which is 1. And for x equals to minus 1, it will be 3 minus minus 1, which is going to be 4. So y equals to 4. So we get our coordinate points as shown in the graph, or as we got earlier, right? So we get the same set of points. So our set of points are indeed 2 and 1, right? So we have the same solution, which is 2 and 1. This is one solution and that is the other one, right? So we have the solution right there, which we can write this one as minus 1, 4, and that one as 2 and 1, which is this solution. And minus 1, 4 is right there. So now you can see algebraically also we have come to the same conclusion. So it is the perfect answer to this very question. Now as an exercise, what you can do here is, you need to find a line which will have just one solution with this given parabola. You can sketch any line you want and prove it algebraically that they have only one point in common. So that is an added exercise for you. But from here, you understand what a linear quadratic system is. Linear quadratic system is any system in which you have at least one line represented along with one parabola with quadratic equation, correct? And when we say solution to those, that means we are trying to find points of intersection or the points which are common to both. You can find the solution graphically or algebraically. So graphically it's easy, but at times it may not be accurate. Algebraically it may take some time to calculate, but you get very accurate results. So those are the advantages. I hope you understand the topic, and with this let's explore more about linear and quadratic systems. Thank you and all the best.